The battlefield sky is no place for compromise or the slightest margin of error. To dominate the low-altitude airspace from 0 to 300 meters, the lethal kill zone, where short-range air defense systems, shoulder-fired missiles, and anti-aircraft artillery lie in constant wait. The military does not simply need a helicopter that flies fast in a conventional sense. They need a flying tank in every meaning of the word. It must be a mechanical entity born to endure the most horrific trauma and respond with the most devastating, destructive power. Everything begins here, in the clinical silence of digital laboratories, where the AH-64E Guardian version is not merely a patchwork upgrade of older models, but a total restructuring of military tactical thought. In this design phase, next-generation supercomputers run millions of complex algorithms, simulating tens of thousands of flight hours in every extreme weather condition imaginable, from blinding desert sandstorms, where sand acts like sandpaper on turbine blades, to the bone-chilling frosts of the Arctic Circle, where ice can turn a rotor into a useless slab of frozen weight. They test the fatigue of the smallest metal links and calculate the fracture limits of every single titanium bolt under the crushing forces of G-loads when the aircraft performs sudden violent maneuvers. Perfection on paper or theoretical figures is never enough for a premier weapon of war. Miniature aerodynamic models made of specialized materials are continuously tortured in supersonic wind tunnels, where cyclonic airflows bombard the surface to ensure every micro vibration and every surplus ounce of drag is detected and eliminated before the design is permitted to step off the screen and into the physical production line. From invisible algorithms and code lines of code, the machine begins to take shape through blood, sweat, and premium solid metal blocks. The core material forming the skeletal frame of this beast is aerospace-grade titanium and ultra-lightweight 7075 T6 aluminum alloys that possess strength far exceeding traditional steel while maintaining the agility required for nap-of-the-earth flight. Under the 1,000-ton pressure of advanced multi-axis CNC milling machines, the initial raw metal blocks are shaved away without mercy, achieving precision down to a millionth of a millimeter, a scale where even the warmth of a human hand could expand the metal enough to ruin the tolerance. In the word of the Apache, a 1 millimeter error is not just a technical flaw, it is the price paid by the lives of the crew and the failure of an entire military campaign. To ensure the machine can survive and stomp forward against the fire of 23 millimeters or even 30 millimeters anti-aircraft cannons, engineers have applied pinnacle composite armor technology. This armor is a multi-layered cake of death defiance. Layers of Kevlar fiber to catch shrapnel, technical ceramics to shatter incoming kinetic penetrators, and advanced carbon fiber matrices pressed together under extreme temperature and pressure conditions. This creates an armored plate much lighter than standard steel, but possessing incredible toughness and impact dispersion capabilities, providing absolute protection for critical fuel cells, which are also self-sealing to prevent catastrophic fires. On the massive assembly line, the fuselage begins to be joined with the signature tandem vertical cockpit structure. This legendary design minimizes the frontal cross-section, turning the helicopter into an extremely difficult target to lock or hit when facing enemy fire head-on. The beauty of the AH-64E does not lie in flashy smoothness. It lies in the brutality of its rugged mechanical geometry, where thousands of load-bearing rivets are exposed on the skin like the scars of a seasoned gladiator, each one representing a point of structural integrity that has been tested to its breaking point. A rigid skeleton, no matter how tough, is useless without a central nervous system and blood vessels to transmit power. For that reason, specialists begin the most meticulous task, routing tens of kilometers of fiber optic cables and sensitive electrical wiring deep into the ribs of the aircraft, utilizing a triple redundant architecture where every critical command has two backup paths. In the Echo version, the requirement for data bandwidth is massive, moving from the old copper wire limitations to high-speed fiber optics to support global battlefield network connectivity, allowing the pilot not only to control the aircraft, but also to command supporting drone swarms through the manned-unmanned teaming (MUM-T) system, effectively turning the pilot into a battlefield conductor. The dual redundant hydraulic system serves as the lifeblood, operating at 3,000 pounds per square inches and arranged to run along separate armored corridors to ensure that if a primary pipe is punctured by shrapnel, intelligent automatic valves will immediately isolate the damaged area and transfer all pressure to the second backup system, maintaining aircraft control even in states of heavy structural damage. The main gearbox, a masterpiece of metallurgical engineering worth millions of dollars, is placed at the center, acting as the bridge between the screaming engines and the massive rotors. It is designed with special run-dry technology, utilizing solid film lubricants and superalloys that allow the gears to continue grinding into each other and transmitting power for 30 minutes after all liquid lubricant has leaked out, providing a precious window of time for the crew to escape a hot zone and perform a safe landing. Once the steel body is complete and fortified, absolute precision robotic arms begin placing the central processing supercomputer, the heart of the cognitive decision aiding system, into the electronics bay. This is the stage of the brain transplant, where billions of calculations per second are activated to turn a heap of inanimate metal into an intelligent combat entity capable of self-identifying threats through its library of electronic signatures. After sealing the internal organs behind titanium alloy plates, the Apache is pulled into a sterile paint booth for the final visual transformation. A specialized, matte, olive drab, chemical agent-resistant coating, caulk, is sprayed evenly over the surface. This is not just ordinary military green. It contains chemical compounds capable of absorbing microwave energy from search radars, scattering infrared radiation from enemy thermal tracking devices, and most importantly, resisting the horrific corrosion of chemical or biological weapons, allowing the aircraft to be decontaminated and returned to the fight. Under this grim matte skin, the helicopter officially becomes a ghost on modern reconnaissance equipment, blending into the shadows of the Earth's terrain. Next comes the installation of the beast's eyes. The TATS PNVS sensor system, mounted on the nose, is a wonder of optoelectronics, housing a multi-spectral suite of thermal imagers and laser designators. It includes the latest generation of infrared thermal imaging lenses that can detect the heat of a cigarette from kilometers away, allowing the pilot to see through pitch-black darkness, salt fog, or thick clouds of dust and smoke. All captured imagery is transmitted directly and displayed synchronously onto the single-eye monocle of the integrated helmet and display sight system, IHATS, creating a strange fusion where the pilot's eye and the aircraft's gun move in a perfect lethal dance. Directly beneath those eyes lie the lethal fangs, the M230 chain gun, a 30mm automatic cannon with an electronic chain-fed mechanism and a specialized recoil damping cradle. This gun can swing exactly according to the pilot's line of sight with near-zero latency, allowing it to spit out a rain of high-explosive, dual-purpose head rounds at 600 rounds per minute. These rounds are designed to pierce armor and then explode, turning light armored targets and enemy infantry into scrap at distances of up to 4,000 meters. On top of the rotor mast, the iconic longbow radar dome is carefully installed, housing the APG 78mm wave radar. This is the most expensive component, allowing the Apache Guardian to scan, detect, and classify up to 128 targets simultaneously in all weather conditions, creating an absolute asymmetric advantage as it can remain completely hidden behind terrain and only pop the radar up to guide Hellfire missiles to destroy the enemy from afar without ever being seen. Before takeoff, the dual powerful T700GE701D turboshaft engines, each producing over 2,000 shaft horsepower, begin their dry run operational test. The whine of turbine blades spinning at tens of thousands of revolutions per minute creates a crisp mechanical sound, signaling that the power is ready to explode. High-intensity vibration tests, known as shake tests, are imposed on the entire fuselage to find any looseness in welds or rivets that might have been missed. Only when the cockpit screen displays the green system nominal text, signifying every system, from the fire suppression to the tactical data link, is perfectly identified, is the inspection closed. The massive hangar doors open, welcoming the brilliant sunlight reflecting off the imposing frame of the AH-64E as it is towed onto the runway in the presence of the engineers who spent years creating it. Every rivet, every wire, and every line of code has led to this moment. A sandstorm begins to rise as the 4 composite main rotor blades, made of high-strength fiberglass and graphite, start to tear through the air. These blades are not just flat boards, they are complex aerodynamic shapes with swept tips to reduce noise and increase lift. As they spin, they create powerful downward vortexes that shake the ground. In the high-speed taxi test, the Iron Beast races forward powerfully, checking tire grip, hydraulic braking systems, and the stability of the tail rotor, which is offset to provide better control in high-torque situations. When the Apache comes to a perfect halt at the end of the runway, the dust gradually settles to reveal a menacing and threatening silhouette. The flight-cleared stamp is officially pressed into the technical logbook, a document that will follow this specific airframe for the next 30 years of its service life. It is not just the completion of an aircraft, it is the birth of a modern war legend, a symbol of imposed power and absolute protection. From cold computer codes at the start, a new king of the low-altitude sky is now ready to take flight, carrying the pride of an unshakable technological peak. But the story of the Echo model goes deeper into the Guardian moniker. The E variant represents a leap in composite technology. The main rotor blades are now all composite, allowing for a higher cruise speed and a much greater climb rate even when fully loaded with 16 Hellfire missiles. The drivetrain has been reinforced to handle the increased torque, and the avionics have been open-sourced in their architecture, meaning the military can plug and play new sensors as they are invented.